All right. Welcome, welcome. So, we are going to be going through, let's check, make sure this works. Hello, chat. Yes, it does. All right, so we're going through some code katas here. Basically, these are tests designed for people who are learning to enhance their skills while developing. So the one that I'm going to be doing it's going to be, I'm going to pick a different one than this. Let's start with something really easy. So we'll say next kata. This is on Codewars.com. We want something that's a little easy, probably around the 8 level. Let's see, this is fine, growth of population. All right, let's train on this. So, in a small town, the population is 1,000 at the beginning of the year. The population regularly increases by 2% per year, and moreover, 50 new inhabitants per year come to live in the town. Okay, so 2% plus 50. How many years does the town need to see the population greater or equal to 1,200? 1,200. Okay, so where's my code? I want to do this. What is this? How do I start you? Output. Results will be shown here. What is this? Dark theme, light theme. Okay. What is this? Do I have Vim key shortcuts? I don't know what that is. Ah, here we go. That's more like it. Okay, so there we go. There's our solution and our tests. The way they do tests here, I don't like particularly. So we're gonna switch over to our terminal here, and we're gonna cd into our Codewars. Make a directory for growth of a population. And we're going to touch two files, kata.go and kata.test.go. The first one I want to work on is kata test. So basically, I want to take their tests and modify them, right? First off, in Go, tests share the same package. I don't need any of their imports. Instead, I'm just going to be using testing. And I set up table-driven tests. So basically, I'm going to have my growth tests, and that's going to be a slice of a struct. Okay, and then that struct is going to have a in that's a string and an out that's a string. And basically, that's where we're going to start with that. And we're going to have struct like that. And we can get rid of their tests. So basically, we expect these. So this is actually interesting. I need various things to go in here. So this is going to be a slice of integers. So we'll say slice of int. And out, we expect an int. Okay? So this should be fun. We have, how many of these? 3 more. So I'm going to take everything to here. Can I do this in visual mode? I'll just delete inside of here, and we'll go back up here, create a slice, and we'll just paste that, right? Does that not work? How do I initialize? Let's find out. So in Go initialize a slice. Oh, you know what? I think it's this. I think it's that. Oops. No. I have no idea what I'm doing. Let's go ahead and look at this. So they specify the size, but I want to initialize it. All right. So they specify the size. We're talking 4. Oh, of int. Right? Okay, perfect. Okay, and then I can probably get rid of that. Yeah. Okay, so that's what we want to do, right? So we've got a slice of int, and we just want to do that twice. Okay. Do it inside of here. No. Delete inside of these. Paste. Repeat. Oop. Paste. Repeat. Paste. Okay. Oh, so this is interesting. This actually ends up with floats. Can we just float these? Oh, and I did it in the wrong space. Son of a. How does that work? Seems okay with that. What happens if I change this to float? Okay. Okay, so now that we've got those, and we've got those set to floats, we'll see generally how this goes. This is my tests, right? So basically, I'm going to iterate over growth tests here and assert these results. And as such, I need my expected results here, which for this one is 15. For this one is 10. For this one is 94. And 151. Okay. There we go. It's just easier for me to test like this, personally. And I don't know what, they're using like weird libraries that I just don't want to mess with. This does what I need it to do. And then all I do is I create a function called like test growth, right? And all I do is I take in t from testing and I iterate, right? So it's like for I, s, or v for value. Yeah, we'll do v for value. No, we'll do tt in the range of growth tests, I think. Oh, wait. There we go. Sorry, I get my languages mixed up. So it's saying that there's an error. I don't think there is. I'm just going to delete that and save again. Yeah. Okay, so now it's like tt.in, you know. So if tt.out does not equal, and this is where we start to get into kata.go, and we get that from here. Okay, so here's where I'm going to be putting the code, but more importantly, this in beyear goes here, right? So in beyear and then tt.in. So what we get out of in beyear, we expect to match our out here. This is our expected out. This is what we're passing in. If it doesn't equal it, then we're just going to say t.error fatal expected. This is going to be a float. I'm not sure. I'm just saying it's digit for now, base 10 number. Got that. And then, of course, we have to pass in what they are. So tt.out. Okay, and then I can take this up here, right? And we're just going to say this is result. Got result. And then back here, okay. It's unhappy. Undefined float. Error, undefined float. Not enough arguments. Okay, so we have to pass in a p0, a percentage, og, and p. Let's find out what those are. So, oh, you know what? I forgot what I was doing. So this is not actually just that. So this would be like tn0, right? Okay, so yank inside of here, and then we would just do right. Well, 1, 2, 3, and 4. Okay. All right. So this gets replaced with 1, replaced with 2, replaced with 3. Okay. All right. What are you complaining about now? Type int as float64. Cannot use type int. Well, you're supposed to be a list of floats, and now you're complaining. Undefined float. So Golang floats, right? What's the float 32, float 64? We just need float 32. 32. Okay. Repeat. 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 Okay. Be happy, damn it. Cannot use float 32 as int. I mean, what about, like, right? Does that make you happy? Cannot use float 32 literal as type int. Oh. Okay. Something like that. Sorry, my bad. So what do we got down here? Cannot use type float32 as an int. Okay, so I'm going to have to cast, well, okay, so this expects int float64, oh that'll be fun, okay, change word, change it to 64, and then this has to change to 64, okay. Getting our types aligned, and then I think I could just like int cast. Yeah. Okay. We'll do that for now. All right. So tests should technically work. We can see here we get an error. Missing a return, so we're just going to return 0, right? Okay, that does what we need. So hard part's done. So now I go to growth of a population, and I go test, right? Okay, and we see that they fail, right? So we expected 15, 10, 94, and 151, and we got 0 all the way around. Perfect. This is what we wanted to see, right? So now we need to implement this function to bring our tests from red to green. All right. Get rid of that, get rid of that. So I'm going to just take this over here for a second, and we're just going to plop it on in here. Okay. All right. In a small town population. So this P0 is such a bad, like, just do that, but okay, whatever. So population 1,000 at the beginning of the year. Population regularly increases by 2%. So population is going to be P0 times 0.02, or 1, right? 102%. Yeah. Sure. Right. So population, we'll say new population. Why are you angry? Constant truncated to an integer. Constant truncated to an integer. Why? Let's Google that. Constant. Oops. Nope, that's not what I wanted. Attempt to access clipboard. Open press. Clipboard copy. There you go. There you go. Okay. Google, what do you say? Do I have to do that? wonder. Find how I do it. How do I declare? I shouldn't have to do that, but let's try it. Var float 64. What? I don't get it. Do I have to float K? Mismatch in, oh. Oh! Okay. Okay, so I just had to match those values. So we have our new population, but we want to like, we're gonna need to round that. We're gonna need to like math floor that. So, because like you can't have a portion of a child. You know what I mean? So import math, and we're just gonna math dot floor whatever number comes out of that. Okay, that should be an integer, right? So I should theoretically be able to return new population, and everything should be good. What's the issue? It should not. It should be an int. I thought that's what math.floor would do. I mean, at that point, let's run a test and see what we got, right? 1, 5, 3. Okay. Okay. So, and if we were to just return B0, yeah. Go away for now. Oh god. There. You happy? Why? I technically did use it. Is equal to new population. Okay? Shush. Ah! Plus 1. Shut up. Okay. Yeah, so perfect. So that's doing what we expect. All right, so I'm just going to undo all that shenanigans I had to do. And we can just do some quick maths like 1500 times 0.02, and we see it's 30 extra people. But we know that it's also going to be plus the 50 new inhabitants. How long will it take to get to 1200? So for, or while, I hope Go has while. Go while. For is goes while. Thanks. For some is, okay. For new population is less than 1200. Do the thing. All right, so in the beginning, new population is just P0. in which case we can just use P0. Right, and then we'll return P0. Try it out. Fail. The reassignment doesn't seem to be working. Well, that makes some sense. We want, let's look at the tests. What is this OG? We'll figure out, but then this 5,000 seems to be like our desired population. So P less than P. Okay. Okay, perfect. So failed, expected 15. Oh, and so we're tracking iterations, right? The years. So for years, we'll just call it iterations, is 0. While it's less, we're going to just increase I. And then just return I. Does that work? I is undefined. I mean, I guess we could do this. Years is equal to 0. Year plus plus. And then return year. Okay. Did we do a thing? Perfect. Numbers are way off, but we're getting numbers, right? So year tracking is working. So we need to figure out, right, so we're not using percentage. So let's go back and read the rest of the kata. All right, so at the end of the first year, there will be 1,000 plus 1,000 times 0.02 plus 50. Okay. Okay. I'm a little confused as to where this plus thing is coming through, but let's figure this out. Okay. For the function nbYear should return n number of entire years needed to get to a population greater than or equal to p. Og is an integer. Yes, thank you. Percent is a positive or null number, and p0 and p are positive integers. Don't forget to convert the percent parameter as percentage in the body of your function. The parameter percent is 2. You have to convert it to, so they're passing in the percentage for me. And then I have to convert it, so it's coming in as 2. So basically, I would have to take 2 multiplied by 0.01. Yeah. So percent is equal to percent times 0.01 converted. And then something like that. Okay, and then we will call this percent. I'm going to assume Og is that. Okay, I did the thing. Really weirdly worded. Like, I'm not even sure what Og is supposed to mean. Like, is it augment? I'm sure they said it. New inhabitants. I would, you know what I mean? Like, where's Og mentioned? Oh, here. Inhabitants coming or leaving each year. Why Og? Whatever. Okay. Either way, I'm pretty happy with this. I wish I could have I outside this scope so I didn't have to declare it up here. I'm generally pretty happy with that. And then I wonder if I even need to do this math floor. You know. Yes, I do. Oh, I didn't need math anymore. Zero dependency. Okay. Right. It's decent, you know. I used everything that they provided. I'm sure when I submit this, I'm not going to be very happy when I look at other people's code, but that's okay. Let's run sample tests. Good. And now this will probably fail. Because they're probably going to have like null numbers and stuff. But it's a pretty easy one. Okay, cool. So everything worked. I'm just going to submit it. Okay. So they did their new percentage down there. I just reassigned percentage right at the top. Let me find mine. Terminal. Oh, wow. Look at all. That's just so much. I feel pretty good about mine, actually. Look what they did. That's weird. Very concise. Very concise. It's almost clever, more than anything. Or like the most, okay, best practice at the very top. Oh, so this is recursion. It's just recursing. I don't feel like it calls for recursion. You know? But it's kind of nice, because n just keeps increasing throughout. And then you don't have to have a for loop with stuff declared outside. Yep. Alright, so that's the general idea, right? That's kata. Alright, so that is where I'm going to end the stream today, because it's 4 o'clock. I will see you all later. Bye.